We're going to try something a little bit different today. We're going to try to simplify, maybe shorten the videos a little bit and give you more time to practice what you've been learning. So today we're going to be covering section 7.4, Trig Identities. And just keep in mind that two functions are said to be identically equal if the left side is equal to the right side. We'll fill in that equal sign there. We call it an identity. And an equation that is not an identity is called a conditional equation. Can't remember ever using those terms, but well, there you have it. So the two types of problems we're going to do today are, number one, using algebra to simplify a trig expression, and that just kind of, oh, I guess you can still see it. Using algebra to simplify trig expressions, but then number two, we're going to establish identities. So first types of problems we're going to use just using algebra. Okay, so getting right to it, we're not going to be talking about anything you don't know already. You've already learned the quotient identities and the reciprocal identities, and this is not a minus sign, it's an equal sign here and here. Apparently the copies didn't come out very well, but anyway, you already know all of these. We talked about the Pythagorean identities in class, so these are the only ones that we're going to use today. One thing I would like to point out that you should really be ready for is when you see not just sine squared plus cosine squared. You have to, whenever you see that, usually that's a trigger that, yeah, okay, we're going to just substitute 1 for that. But also, when you subtract sine squared from both sides, you're going to see 1 minus sine squared, and whenever you see that, you're allowed to replace that with cosine squared of theta. And likewise, when you subtract cosine squared of theta from both sides of that equation, then you get to replace that with sine squared. So these are the ones that are used the most often. Okay, so look at those, make sure you're ready for those, and let's go ahead and get going. So the first example is just simplifying a tangent over secant. And one of the good rules of thumb, kind of like your bread and butter, would be change everything to sine and cosine. Okay, I'll abbreviate a lot here. So first thing you should be thinking about, how can I change these to sine and cosine? So we have tangent of theta times the secant of theta, times 1 over the secant of theta, okay, and the tangent of theta, we know that to be sine of theta over cosine theta, okay, and 1 over secant of theta, we know that that is cosine of theta, and obviously we can see here we can cancel the cosines, and so we just get the sine of theta. Okay, that's it. So if we use our rule of thumb, that important stuff here to remember, just change to sine and cosine, and many times things just fall into place. Okay, so that's one rule of thumb there. Second rule of thumb would be get everything down to one fraction. Okay, so so this one would be change to one fraction. In other words, you have to simplify an expression. Okay, first expression, how do you simplify it? Well, it's already one fraction, so change to sine and cosine. Okay, it gives you a good idea where to start. So that's the hardest part to these problems, is knowing, well, how do I start them? What do I do first? Okay, well, here you see we already have sines, and we don't have any other reciprocal functions. So, but we do have two fractions, and keeping in mind a good rule of thumb is get it down to one fraction. So what we're going to do here is multiplying the second fraction by 1 minus sine of u. And why are we doing this? Because when we add fractions, we have to have a common denominator. So we're going to multiply top and bottom of the second fraction by 1 minus sine of u. And let's see if I can squeeze that into this other one here. And multiplying the top and bottom of the second fraction by 1 plus the sine of u. Because as you can see, hopefully as you can see, that the lowest common denominator would be 1 plus sine of u times 1 minus sine of u. And because of that, we need to make sure we get each denominator having both of those factors in them. So in order to do that, 1 plus sine of u, multiplying top and bottom of this first fraction by 1 plus sine of u. Okay, and then our common denominator again would be 1 plus the sine of u times 1 minus the sine of u, and the numerator becomes 1 plus sine of u. And you know, I didn't mention this before, but what is really helpful, once you get all of the trig functions in your expression down to just sine and cosine, I like to just write it as 1 plus s. So anytime I have just sines and cosines, I just use s for sine and c for cosine. And it's that 1 plus s, I didn't need to put the parentheses there, plus 1 minus s. Okay, and then you can see that the sine minus sine in the numerator are going to cancel. Sine minus sine, and we get 1 plus 1, so we get 2. Okay, so we get 2 in the numerator. And then the denominator we have 1 plus sine, 1 minus sine. Well, when you multiply these two together, you get 1 minus 1 minus sine squared. And we know, like I said, 1 minus sine squared is cosine squared. Okay, and 2 over cosine squared. You could leave it like that. Sometimes you'd see it as 2 secant squared. Okay, there you go. And now, in the second one on this slide, we see we have 1 minus cosine squared. Well, that's just sine squared. That's a v now. Okay, that's sine squared. And down here we can see we have a factor of sine of v that's common to both terms, and we can factor that out. Sine of v, 1 plus cosine of v. And then we can see that we have, we're able to cancel now sine squared, which is sine of v times sine of v. And so we cancel the squared, and we cancel this sine of v. So we cancel the like factors, and we just get sine of v over 1 plus cosine of v. Not a whole lot more you can do with that, so we're going to leave that alone. Okay, so that's it. That's simplifying trig expressions using the two main techniques would be combine to one fraction, but then also change to sine and cosine. So you got to be careful here. Just a quick recap of this part. Be really careful because students tend to do things like this. They tend to see sine of theta, let's say, plus cosine of theta over sine of theta. Okay, you're tempted because your brain, your eyes see this. Your brain wants to just cancel those signs, but you know you can't do that because when you have a plus sign in between here, that prevents you from being able to cancel one of those terms in the numerator. Just like if you had 4 plus 6 divided by 4, well, you can't cancel the 4's. That would be 10 over 4. Then you can cancel because you have 5 times 2 over 2 times 2, and you can cancel the 2's, then you get 5 halves. If you cancel the 4's here, you'd get 6, and we know that 6 is not 5 halves. So if you can't do that way back when you're canceling fractions, then you can't do that here when we have trig functions in there. Okay, so just be careful. All right, so that's 9 minutes. We'll do the next type of example in the next video.